Good afternoon, everybody, and thanks for joining me today while I spend just a little bit of time walking you through MapleSim and specifically MapleSim 2019 and what's new with our newest release, which was just put out a few days ago. So a bit about MapleSim in case you're not familiar. MapleSim is our system-level multi-domain modeling and simulation tool. And it is wonderful for trying to get a handle on the interaction between all the different domains of a product that you're designing. So that means you can start to model, say, your electrical system alongside your mechanical system and start to understand what the kind of interactions would be between all these different areas that historically you may not really come to understand until it's time to prototype. So we allow you to build these models up with the drag and drop interface, allow you to visualize them using the CAD that you might already have from another program. And we allow you to export these models in a whole range of formats that lets you plug them in to your toolchain for product development. For MapleSim 2019, we focused on a few key areas specifically to help with a handful of different markets, especially those of you in the automation world. We've improved performance across the board, so simulations run faster, which is especially important if you're trying to do some sort of optimization where you may need to run the thing many times. So that runs faster, and the scope of what can be modeled has greatly increased as well. So we have new component libraries, and for many of our current libraries, we've added more components. So when you're trying to get a model together easily, you've just got more already there waiting for you that you can drag and drop in, tweak the parameters a little bit, and away you go. So there's even more opportunity there. And like I said about sending your model off down your tool chain to different kinds of programs, we now have an even greater range of connectivity options available. So these, especially with the functional mockup interface standard, if those of you are familiar with that, you can now export your model to a wider range of FMI standards, which can be important for different kinds of real-time simulations. So all this to say, you'll be able to simulate things faster, you'll be able to model a much greater range of different kinds of phenomena, and you can experience a lot less roadblocks when you're trying to plug this thing in and make it work for you in other tools down the line. A special note for 2019, we have an additional product available now for MapleSim. It's called the B&R MapleSim connector. And for those of you who have any connection to machine design or the automation industry, what this is it's a really tightly integrated connector that allows you to take a MapleSim model and have it work from directly within B&R Automation Studio. And this really unlocks a lot of potential to easily perform things like motor sizing. You get really accurate senses of the torques and the loads that are being experienced by the design that you're proposing. And further to that, when you actually need to have folks in your company perform the PLC design and actually control the machine that you're making, now within Automation Studio, you can test that controller code directly off a physics-based model of the machine that you're trying to design for. So that's going to reduce a lot of errors when it's time for that often very messy stage of commissioning the machine. So let's dig into a few details here about how we've improved MapleSim for 2019. First thing is performance, so faster overall. And some specifics here. So now when it comes to running simulations faster, the way that we handle constraints are just more efficient. And for some of you, this might matter a lot, especially if you need to do some sort of real-time simulation. And it's important to note that you don't lose any fidelity in how we choose to run things faster as we improve MapleSim, so you'll still get all the accuracy that you're used to. Secondly, the models you export are also going to run faster now because of all these efficiencies. So if you're used to bringing this into, say, Simulink, into a variety of tools, things will continue to run even faster than you're used to. And for those of you who have been, say, working on MapleSim models for a while, or know that you have some model that requires a lot of different pieces at play, now your large models are going to be way more responsive. And this is going to be really of note for making those quick design changes. You'll be able just to whip through them a lot faster and the way that you can manipulate models now, there'll be a lot less slowdowns. So this is really important for companies who have been sort of iterating on their MapleSim models for a long time. They'll continue to be even faster. Moving on to what I was speaking about with the increased modeling scope, there's a whole whack of ways now that we have improved the scope of the components available in libraries across the board. Say with the MapleSim Hydraulics library, we have added 25 new components, and that includes restrictions and valves, directional valve controls. So really there's a handful of new components there, and we've also made this library more stable for real-time simulations if you need to do numerical simulation. Our electrical library has new components as well. We've got new sensors, multi-phase sensors, and more signal blocks, and more power converters. So the electrical library has gotten even better. The MapleSim Heat Transfer library has a handful of new components as well, and those are going to be based on a range of couple new different geometries. And generally, when you're trying to perform that sort of coarse grain heat transfer analysis that you can do with our library, you've got more options available now to make that happen. We've also updated our Modelica support in a variety of ways. So this includes the Spice3 library from Modelica. We now support the Modelica synchronous library, which for some of you is going to be very important. We also support the Modelica multibody library. And lastly, just across the board, we've updated our Modelica support to one of the latest versions, 3.2.3. So for those of you who are looking to import different libraries from Modelica, or you have certain kinds of code written in Modelica, our support continues to remain strong, and we're always updating that. One new component library that was not on the last slide, thought it deserved its own, is an entirely new component library we have from Modelon. And this is the MapleSim Engine Dynamics Library. And this is a 80+ component library that provides ways to model, simulate, and analyze the performance of combustion engines. Lets you do this a lot easier than you otherwise would have before. And some of these components, they help you capture the fluid mechanics, the thermodynamics, the air-gas exchange, just to name a few of the combustion engine that you're working on. It also lets you simplify your control design projects because you're allowed to model the transient engine responses and then perform hardware-in-the-loop verification. All these things are already created to a degree to let you sort of hit the ground running here and use pre-built components and analysis workflows to make that happen easier. And lastly, the Engine Dynamics library also includes ways to analyze the flow path of exhaust fumes, which are things that are really important when you're trying to design a combustion engine. So being able to understand how things like exhaust gas, recirculation, loops work, that can all be done within this component library. And then further to that, because you're working within MapleSim, you can then take the engine dynamics that you're modeling here and start to hook it up with a variety of other mechanics and multi-body systems that are already available within MapleSim. So this is just going to unlock a better amount of modeling and an easier way to get this part done for you to then hook this up into a multi-domain system that would be of interest to you. And lastly, to speak about the ways that this can be connected more down the line for your toolchain, we've got a whole bunch of new ways that you can actually connect better. And this means that there are more simulation options when running imported models from other systems. So your imported FMUs can now be run using MapleSim's variable step solvers as well as the fixed step solvers. So for certain kinds of connectivity, this is really important. So we're a lot more functional and able to handle more kinds of model solvers. We've also updated our FMI connector to support the FMI 2.0 variable step co-simulation, where previously this was limited to fixed step. We can now do them both, which is important for a variety of different kinds of models. And there we have an analysis app, and we've improved these. We've allowed you to get your results to Microsoft Excel and other spreadsheet tools a lot easier. So when you're running analysis within our program, you can get those results to maybe the common piece of software if it's an Excel-based tool that you're already used to. So we let you get them out easier. So I wanted to spend just a couple minutes talking about this new product I'd mentioned, the B&R MapleSim connector. So this connector, like I said, it's a wonderful integrated solution to allow you to perform things like motor sizing and PLC code testing or virtual commissioning within a B&R toolchain. So this helps bring MapleSim and B&R Automation Studio a lot closer together, along with B&R's ServoSoft. So a typical workflow for someone would allow them to use their CAD files to create the MapleSim machine model simply within MapleSim. And with only a handful of more modifications in MapleSim, we're going to be able to help bring that model alive so that it can then be exported to be used in either B&R Automation Studio, or if we're looking to do some sizing for our motors and servo drives. Now that we've gotten our precise loading requirements and torque requirements from the MapleSim model, we can bring that into ServoSoft and then just pick the motors off the catalog that are going to work for us with a much higher degree of confidence than was done before. And then if you want to take it a step further and really get into that virtual commissioning, you can take that MapleSim model, we export it to B&R Automation Studio, and then we just use that as a test platform for the PLC code that you're creating in B&R Automation Studio. And something that no other connection has right now, but that we're able to do, is we're able to give you the 3D visualization of that machine directly within B&R Automation Studio. So you're going to be able to see in a 3D CAD-based model what your machine looks like as it's being controlled with the PLC code that you're creating. So it's a really wonderful virtual way to understand if you're sort of on track with the kind of design that you're creating. Just to talk a sec about these MapleSim models we're talking about. We call these digital twins, and you may have heard this word out there in industry. It's certainly popping up everywhere. But just to differentiate, some folks, when they think about digital twins, they're looking at this image you see below. They're looking at a plant level or a line level digital twin, where they're interested in the sort of discrete events of how all these machines work together, how fast this whole line can have product run through it, and how to lay a plant out. And that's certainly a kind of digital twin, but there's a few different kinds. So when we talk about using this B&R MapleSim connector to help with digital twins and virtual commissioning, we're referring to the machine level digital twin, which is the kind of twin that we create within MapleSim. And like I said before, this is not really about the sequencing of how every machine works together, but this is how to size motors. This is how to figure out how fast your machine can run before the motor itself breaks or before there's way too much, say, thermal buildup in some area. This is a way to figure out if the design of your machine could physically permit a certain kind of throughput. And then this is the kind of digital twin also that gets you into virtual commissioning. For somebody who's just hearing this term or has heard a bit about it, we know it's far too common that someone understands a little bit of what a digital twin is, but that world seems so far removed from the current culture and processes at their company. But simply put, if you have a CAD model of some mechanism, you can just import that into MapleSim, and you can create a simple digital twin, sort of like how you'll see here. You'd import that CAD into MapleSim. We have a wizard that helps guide you through how to just set up a few coordinates, and then we pull in all the inertias and all the masses of those parts. And then your CAD will end up looking like a series of blocks, a series of components that resemble the model itself you just brought in. Then your job now is just to develop the MapleSim model by just adding some joints, adding some motors, things like that, and then define the motion path. And we have a built-in app that helps you define the proposed motion of the machine that you built. So you get that all set up, and then you just run simulate. And for many models, between 30 seconds and a minute and a half later, you've got your analysis done, and you can see all the different loading requirements, and then you can start to verify the design and make sure that you've chosen the right motors or gearboxes or whatever other component that you're curious about. And that's just a simple workflow to get off the ground with a digital twin. If you have a little bit of experience with something like this, this is a process that takes less than an hour to set up. But of course, as you get learning, it might take a little bit longer. But to create something on this scale is it's not nearly as hard as some people might think. But of course, you can always make this a higher fidelity model as you continue on your journey of iterating on this digital twin. And if it's something that you're not interested in, trying to work on this yourself, we offer training and services, and we're willing to do pilot projects with you where we take on this first process for you. We can help meet your project requirements. We'll create a model that you're happy with, and then we can help show you how we did that so that you can do this in the future. But we're here with our consulting group to make it a reliable success for you to take something like this on. And that helps you get results out of a digital twin in days rather than months, or weeks rather than years. We make sure this goes fast for you. And then to finish off that sort of workflow, as you saw before, we're at the point now where we've got our digital twin model. Now we just export that over using that FMI standard we talked about before. So you have this FMU, it's a file on your computer now. B&R Automation Studio reads that in, and then from there, that's where we get all those benefits I talked about. Not only, say, validating how your machine's going to move and if your control code is set up properly, but we have a lot of customers who are more interested in, say, the safety elements. They want to test scenarios that would very likely push their machine to the limit or break it. And they're going to do that within Automation Studio with our digital twin, and they're going to be able to see just what kind of limits exist and what kind of environments and contexts would create a fault scenario for their machine. Way cheaper to do this and to break your digital model than to break a physical prototype. So you got a lot of folks that are really interested in experimenting with how the machine fails, but doing that with a digital twin. Just to finish out here, we've talked a lot about now MapleSim 2019 and how it fits into your tool chain better. You can model more with it, and everything runs faster. And just wanted to reiterate that our application engineering group is here to help with really every step of this process, really to help make sure that if and hopefully when your company decides to take the next step in how they do machine design, that it'll be a guaranteed success. That means that we can help with things like creating your digital twin. We help with custom-built applications so that if you just know you have a certain workflow and you need to size gearboxes, we create a custom-built app that just creates a skin that helps guide that process easily for folks to use. So we have all different sorts of ways that we can help you be successful using digital twins. And if you have any other questions, feel free to visit our website at maplesoft.com.